Hello, welcome to this video. In this video, I'm going to show you guys how to get the sine wave. Okay, so here I have decimals opened, and what I have done is I have put in y equals to sine x, and this is the wave that you see here. And the reason why we call it a wave is because it kind of repeats itself. It repeats itself forever, unless we fix a domain for it. But if without any limit, so to speak, we the sine wave is just gonna keep on continuing to the left and to the right. All right. For now, I'm gonna fix my setting here, and you guys will see that I want to show you guys how to get this curve. Okay, how to get this sine wave from the unit circle. So now, on the left-hand side, I have my unit circle with me, and we know that when we talk about sine of any angle, we're looking at the y coordinates, right? So sine of 0 gives me 0, sine of pi over 6 gives me half, sine of pi over 4 gives me root 2 over 2, so on and so forth. So when we are trying to come up with the sine wave, my x-axis, my horizontal x-axis, they represent angles. So if I have a 0, that means it is 0 radian. If I have a pi, that means it's pi radian. If I have 2 pi, then that means it's 2 pi radian. My x represent my angles, okay? And my y-axis, my vertical axis, represent sine of that angle. So sine of 0 gives me 0, which is true. Sine of 0 gives me 0. And sine of pi also gives me 0. Sine of pi, sine of pi gives us 0. Sine of pi gives us 0. So if I take half pi, I should get, if my x is half pi, then my sine value should be 1. So half pi is here. Half pi, my sine of half pi gives me 1. So this is how we interpret the graph, okay? But now, let's see how we can get the shape from my unit circle. The first angle that I'm going to have, x1 represent angle, just keep that in mind. I'm going to hide my sine wave, be 0. So this is decimals. I'm using the table function in decimals, and it is just going to automatically give me the y value, which is over here, right? And then I'm going to have the next angle is going to be pi over 6, which is 0.5. That's neat. And you can also see that they have added a point there as well. The next angle will be pi over 4, which is 0.707 blah blah blah. That is simply root 2 over 2. Okay, that's the root 2 over 2 here on the unit circle. Next, it'll be pi over 6, and that will be, pi over 3. My bad. Pi over 3, and the sine is root 3 over 2, which is 0.8666, 0.02, blah 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 blah. Okay, so this is root 3 over 2. The next angle will be pi over 2, and it is 1. Okay, and I'll continue with this. So the next angle will be 2 pi over 3. So the y is going to be root 3 over 2, so that's good. Next one will be 3 pi over 4. And the angle, so the sine value is going to be root 2 over 2. And the next angle is 5 pi over 6. Sine of 5 pi over 6, half, 0.5. The next one will be pi. And sine pi gives us 0. Next one, 7 pi over 6. My y is negative half. Next one, 5 pi over 4. My y is negative root 2 over 2. Okay. Next one, 4 pi over 3. My y is negative root 3 over 2. Next one is 3 pi over 2. My y is -1. Next one, 5 pi over 3. My y is -√3 over 2, which is the value here. 7 pi over 4 next. My y is -√2 over 2. This is -√2 over 2. And finally, almost done. 11 pi over 6. I have -½ And finally, 2 pi. I'm back to where I started. So my y value is 0 again. So there you go. So we can see the wave, the shape of the wave already, just by going around the unit circle once in the positive. If turn that in the positive direction and turn that one complete circle, I get this shape. Okay. So let's say today, if I want to get this point, but over here, what do I do? So let's look at the unit circle then. This is pi over 6, which is here. Pi over 6 is here. If I want to get to the same spot, but I can just do that by rotating it. So rotating in the positive direction. So I'm going to rotate that 2 pi. So that point will be, it should be pi over 6 plus 2 pi, and the y value is going to be 0.5. So that's 13 pi over 6. Okay. Let's say today I want to get this point, but on the negative side, so somewhere here, right, somewhere here. Oh, sorry, 5 pi over 6, so maybe somewhere here. Then I will have to minus 2 pi, right? So 5 pi over 6 minus 2 pi, I will get 5 pi over 6 minus 2 pi. The y value will be the same because I'm back to the same spot. So this is -7 pi over 6, right? So there you go. So that's how. That's why when we were talking about rotating around the unit circle, it is a pretty important skill. It's very important, and because you can keep on turning in the positive direction, in the negative direction. That's why the sine graph looks like that, and it's just going to keep on going to the left and to the right. Okay. Now, please feel free to rewatch what I have been talking about in this video, right? Before you proceed to the next section, where I will be talking about a few special points, and also what's an amplitude, what's a period of a sine graph. So please pause the video, kind of reflect on what you have learned from the past 8 minutes, and then you continue, right? All right. Now I'm just going to. I'm not going to show this tables anymore. I'm just going to use my sine curve, right? My sine curve. I'll delete these points. All right. So let's look at my sine curve. The first thing that you need to know for a sine graph is a very simple sine graph, y equals to sine x. It will always pass through the origin. So, and then on the right hand side, it's going to go up. On the left hand side, it's going to go down. But it will pass through the origin, go up to a maximum point, come down to the 0 again, go to the minimum point, go back to 0. Okay? So now you can kind of see that it repeats. It repeats over a period of 2 pi, right? Start from here, up, down, up again. So it repeats over a period of 2 pi, and this 2 pi value is called the period. Okay, So period is basically how long does it take for this wave to repeat itself. So start from here, up, down, up again. This is 2 pi, right? The period is 2 pi. And because it repeats, sine function, cosine function, actually all the trig functions, we call them periodic. This is just a fancy word for repeat. Okay, they are all periodic, which means they repeat each other. They just keep on repeating. All right. Now, the next thing that I would like to point out is something that is called the principal axis. The principal axis. If you look at the wave, the sine wave, you can see that I have this. There is this horizontal line, and right now that's my x-axis that lies right in the middle of your sine wave. So you have like it is almost like a mirror, but not exactly a perfect reflection. But you can see that it's almost like half of the sine wave is above, half of the sine wave is below, above, below, and this horizontal axis, the x-axis for now, lies right in the middle. For now, we call that the principal axis. Okay, so this horizontal axis is called the principal axis, and sometimes you guys will be asked to find the equation. Since it is the x-axis, it will be y equals 0. So now my principal axis is y equals 0. Okay, but that's not always true, because sometimes we can have transformations. If the whole sine graph is being moved up or down, then your principal axis is going to change. All right, we'll talk about that in the future videos. The last thing I would like to talk about is called amplitude. Okay, so what's an amplitude? Amplitude is simply the distance, okay, I repeat, the distance from the principal axis to the maximum point. So I'm talking about this vertical distance here. Since it's distance, it cannot be negative. So from here, the principal axis straight up, which is 1. So in this case, my amplitude is 1. Or I can use the minimum point from the principal axis straight down, even though it's -1, but I'm talking about distance. So so amplitude in this case is equal to 1. There's no amplitude, make sure it's just a distance, yeah? So if it's distance, there's no negative or positive. It should always be positive, okay? You can either use the maximum point, refer to your principal axis, or you can use the minimum point, refer back to your principal axis. That vertical distance is your amplitude. Okay, I hope you guys get the idea of some special properties of a sine wave and how the shape of the wave comes about. In the next video, I'll be talking about cosine wave. Feel free to rewatch this video, and I will take notes. Make sure you take notes, and I'll see ya. Bye bye.